Hello, I'm Mark Tucker,
Hey, I'm Alan Furstenberg. We are Two Voice Devs.
Two Voice Devs. Good to see you again, Alan.
As always, it is great to see you, Mark. It's been there's always a lot going on, and I'm glad when we have these chances to kind of touch base about
Yeah,
what we're working on and stuff we've discovered and so forth.
yeah, it's fun to kind of discover something new and kind of dig in a little bit, get excited about it, be able to share it. So
Yeah, no, so I mean, and that leads into what I think we wanted to talk about today, and that's that you had messaged me about something called TypeChat, which you were interested in, and we're looking into, and I thought it sounded interesting. So why don't you tell us about it?
yes, so like you said, TypeChat is something that Microsoft put out. It's on GitHub. It's open source. I think they originally put it out July or August of this year, but I've just discovered it just recently. And they do have some code examples. Now, the kind of the short story of TypeChat is that it merges the LLMs with TypeScript, and that's where it gets the name
Okay.
TypeChat. And the kind of the idea is that similar to writing prompts from hand or using something like LangChain to create prompts, this creates prompts in such a way that it it is instructing the LLM to return the response back in a JSON format that matches a specific TypeScript schema.
Now, and we've kind of talked about some of this
Yeah,
in the past before. I mean, we've talked about things like OpenAI's functions, which do that sort of thing for certain predefined functions. And we've often talked about how we like using the notion of turning this fuzzy human input into a data structure, a discrete output. I've
right.
been talking about this a lot recently. So this seems really appealing. I can kind of see what use it would be, but I feel like also there's something that's kind of in particular that us as voice developers also would what's the best way to put this, would resonate with about kind of their objectives with this, at least from what I saw in the documentation of it.
Yeah, and the documentation is okay, but they have the source code of TypeChat, but then there's a number of different examples. And then when you jump into the examples, you're like, oh, this is the similarities across the examples, but then it kind of builds on it on more and more complex, and you start to see, oh, this is kind of cool. So we'll talk about kind of just generally what TypeChat is, and then we can talk a little bit about some of the examples.
Okay.
So what TypeChat does is, I guess the first thing you do is you specify which model you're going to use for TypeChat. And right now, that is either GPT 3.5 Turbo or GPT-4. Those are
Oh,
the two
big
models
surprise.
that,
Those are the two options that
yeah,
Microsoft is giving
yeah.
us.
No, it's not saying that you can't use TypeChat or this approach with other LLMs. It's just where they've put their focus or where they've started. And typically you want an LLM that allows to do voice, but also understands code, because it does rely heavily on the code side of things. And just kind of as an aside, I've used Chat GPT a lot in the last 6 months, where I'm like, hey, give me an example of this in JavaScript, or how would you do this in such and such, and oh, make that TypeScript now, or here's this code sample. What does this code sample do? And it kind of explains, or like, how would you change it? So if your LLM understands code, then you're kind of on a good starting point. If the LLM that you're choosing to do this with doesn't really understand code, then you're kind of lost. There's no nothing that that TypeChat's going to magically do for you.
I mean, in some ways that's interesting though, because it's not like it's generating code. It's just generating a data structure. Well, but I guess it needs to sorry. Okay.
Yeah, we'll get to, well, yeah,
Yeah.
we'll get to that. So that the first thing is you have to specify a model, and you can either specify if you're going directly against OpenAI's API, or if you're going against OpenAI in Azure. So those are kind of, you select the model. The next part is that you need to define a TypeScript schema. And that is in a separate, file. And this may or may not be the exact, objects and stuff that you're going to use in your code for other things, but this is the structure that you want your data coming back from the LLM to be in.
Mm-hmm.
And
it occurs to me that this is why it would need to understand code, because you're essentially handing it TypeScript.
Yeah, so the prompt is basically, some boilerplate, blah, blah, blah. I want you to return it in JSON following the schema of this object ID. Splat, here's the whole TypeScript file. It really is picking up, and from the best that I can see, it looks at what you name types. It looks at what you name fields. If you've got some hard-coded strings in there, like the very first example is an interface that has one field called sentiment, and it can be of one of three strings, positive, negative, or neutral. And so then when you're saying, I want this response to come back in JSON that matches this thing, it's taking a look at the phrase that you said, like, I enjoyed going to the park today. It looks at that and it says, oh, okay, I need to try to fit that to this. And so it's taking clues from the actual strings that are inside your TypeScript. It also, I think, takes clues from the comments that you decorate different methods and fields with.
Interesting. Okay.
So so that's why it has to understand code. It kind of flips the reverse, where I say, well, this is what I want to do. Show me the code. It's like, here's this code, match this input to this code.
To the schema that is defined by this code.
Yeah, exactly. And so, building that prompt, you could hand code that, but there's some nice helper methods that help you do that. And you basically just read the TypeScript file and you go ahead and create, this translator that includes the model. So I'm going to use ChatGPT 3.5 Turbo, and here's the TypeScript. And then you call a method for translate, and you pass in the string that you want to be the input. So all that goes into the prompt. Behind the scenes, what happens is that the result comes back, and it's checked to see, one, if it's JSON, two, if it matches the schema of the TypeScript file that you've included.
Not bad. Okay.
And so then you've got at least a certain amount of confidence that it's matching what you've asked for. And if it matches, then it gives you the response. Then you can use this object and feel pretty confident that it's matching what you wanted to. If it doesn't match, then what it does is it takes the output from the TypeScript compiler and does an additional prompt that asks the LLM to correct it based on the error message. Based on the error message. So it's like just a one-level correction, where it can then get a little bit extra chance to get it right. There are some kind of, I don't know if they're as far as best practices yet, but there are some ways that you can structure the types, where if you've got certain things, you can have certain things be optional. That's one way to approach it. Or you might be able to define types and have like an unknown type, and so you can then at least capture what was said, and that it doesn't match anything else in your types definition. And it's strange, because the TypeScript that you define, you can either think of this is just the structure of the data that I want to get back. So like you could say, list the top 5 albums or whatever, and just let the LLM give you back the answer that it thinks based on that, but then fit it to a specific structure. So that's kind of like just fitting data. But you could also have it so it fits commands. Like there's a calendar example that was like, I want to add an event, I want to delete an event. And you start thinking about things like that, and this is all structured as interfaces with an action field you start thinking like, well, this seems really close to an intent model.
Yeah, I was going to say this seems very intent-like.
Yeah.
With slot filling, with
Yeah.
And I feel like that's almost part of there's kind of a question that has me curious is, if you've defined a type that says that, this field is mandatory and the user does not provide information that fills that field, what does it do? Does it send back something that tries to do prompt filling? Does it flag an error saying this field is mandatory and I don't have this information? Does it hallucinate and put something in there? I'm curious what it does.
Yeah, I don't think it really tries to do slot filling. I think it just doesn't match the type. But I have seen examples, some of the examples where it says,
oh, that's an interesting point. Okay.
Default value is this. So you can add a comment that says that the default topping is pepperoni or something like that. If you don't specify it, or the default size is large.
Well, I mean, so default size is large, that kind of makes sense. Or, default topping being unknown. And so, being undefined and allowing undefined. And if this means now you need to add code that checks for those fields to say, well, if this is undefined, then prompt for it. Prompt for the field, manually prompt for these fields ourselves.
Yeah, and so I think that would be kind of the pattern where you would have certain fields be in TypeScript. It would be question mark, meaning that it's
right.
Accept a value or no, or undefined. And if that's the case, then you can then check if you get the object back, you can then check to see if that property exists, and if it doesn't, then you can figure out if you need to ask some prompts for filling.
Well, I mean, the other alternative is that as part of the built-in prompt, as part of the schema, you can define something like a missing fields type, which is an array of objects that indicate which fields are not specified and need to be specified.
Oh.
And it may return that object, and now you have, well, okay, this is the additional information I need to collect that you prompt the user for. The question then is, how does it go fill it in with the stuff that was provided? I don't know. These are, I mean,
yeah. So right now I think it's pretty simple. I don't think it. I don't think it. Oh, sorry. Go ahead.
No. I think I was about to say the same thing that you were. Is that it feels like right now, there's a lot of people that are thinking about ideas like this and saying, oh, we can replace our old intent-based systems with LLM-based systems. And that's probably true, but it's not clear to me yet that, and I've said this a few times now, that there's a lot that the LLM community needs to learn from the voice community. And I feel like this is one of those things, that slot filling and prompting for slot filling is something that isn't there yet on any of these systems. Everyone is thinking, oh, this is great. It'll fill in the fields when the user specifies it. And, if they don't, that's fine. Users no longer have to think carefully about it. And I'm like, well, this is even worse. Users have to think more about it. And I feel like we'll get there, but I'm not sure. And, I don't know who is thinking about this and who is trying to find the solutions that do this, that truly replace what Dialogflow did.
Yeah.
What Alexa has been, because Dialogflow did this. So I don't know if anybody out there does know libraries that are doing this already. I'd love to know. So I don't have to convince somebody to go write it. But
so because the plus is that you don't have to train an LLM, like this is the language model that I understand. The disadvantage is that I don't get to train the LLM
model. Right.
Yeah. So and so LLMs are good at like natural understanding, like figuring out. And so I like a coworker today was asking like, well, where do you put the utterances? And I'm like, I don't know that you need to put the utterances. If you have a description, or maybe you could even give some example utterances if there were some certain ones that you you cared that matched, but the idea is that it's trying to glean enough from the code that it would say, oh, this whole range of things match, but you don't get anything like a confidence score, like how close something matches, and if it is above a certain threshold, or
Well,
there's
but
a lot
there's
of
the
things you
thing.
don't
You
get
could
with
ask
LLM.
for a confidence score. You just put a field in that is, confidence phrase match, and put a comment in it that says how confident, on a range of 0 to 1, how confident are you that what the user said matches or fits into this data structure.
Yeah, we could try it.
And while you're at it, add in a field that says, this is the entire utterance from the user.
Yeah,
I mean,
yeah.
That's the thing, is you can do these sorts of things. I
Yeah.
guess you don't need the entire utterance, but the concept is there that you can build the data structure however you want and leave it up to the LLM to figure out how to fill it in.
And then you have to determine if you trust the value that the LLM filled in.
Well, yeah.
Right. So let's see what right now it's very simple. It doesn't even keep like a chat history or something. It's like every prompt is a new prompt that's being sent to the LLM. There is a pull request to add kind of a chat history to this, but that hasn't been pulled in yet. I have questions like, if I want this in Portuguese, do I need to have a schema where all the
field
types
names are
and
Portuguese,
fields names are in Portuguese, and all the strings and comments are also in Portuguese? Or is it able to translate from one language to another? Okay, I don't know the answers to how you would handle multi-language on this, but I at least thought it was interesting that it tried to fit your response to a specific schema, validated the schema, and tried to correct it once if it didn't.
Yeah, no, that makes it's an interesting approach, and I feel like it's the start. I feel like there's a lot there's a lot that needs to be done still.
So there's one more thing that I wanted to talk about. We talked about right now how you can define types like interfaces in TypeScript, and have the data kind of snap to the schema on the response. There is a separate translator that is part of this package called the program translator. And what you do is you define in TypeScript a type that has functions, that has parameters. And it's just kind of like the definition of the function.
Okay.
In JSON format, right? But what you can do is then feed it to the program translator, and it turns that into kind of a structure that then gets passed off to a handler. So one of the easiest example that they have is the math example, and it allows you to do like 1 + 1. And the numbers can be written out in text form or in numeric form, but it handles addition, subtraction, multiplication, division. So it takes that text string coming in as the input, and it actually does the calculation. Well, how does it do the calculations? It's not doing a JavaScript eval. It's not doing anything dangerous like that, but it passes that structure that says, oh, I need this thing that I have is a multiply function call with 2 arguments, and here's the value for argument 1 and argument 2. It passes that to a handler, and you basically have a switch statement on func that says this is the function, and then you can say, oh, if the function was multiplied, then I take argument 1 and I times it by argument 2, and I return the response back.
So hang on a second. Does it implement that function, or do you have to implement that function? Okay. So really all it's doing is it's adding stuff to the data structure that gets sent back, and the library is intercepting that, knows what its special stuff is, strips that out, and then hands the rest to the function that you have defined, or
the handler that you've
handler that you've defined for these functions. Okay, that's pretty cool. I mean, that's useful because that's probably literally the first thing that I would have done with it. So it makes sense that they built that in. I like that.
So that's the simple example. The more complicated example is like a Spotify integration. So you can turn it off so you can just run it locally, but I think the example, all the stuff's there that you can turn it on and actually call the Spotify API. But it has things like play, pause, volume up, volume down, create a playlist. And so what it actually does is it takes the sentence that you type in. So I think one of the sentences is something like, find the last 80 songs I've played and divide them into classical and blues and create a playlist for each, naming the classical one classic 8 or something like that. So that is the text input, and it turns those in to a series of calls. So it's like, oh, I need to first do a search of the last 80.
Interesting.
Then I need to I need to filter that. And there's a reference back to, go back to the output of the first thing. And I want you to filter that by this certain type. And then I want you to add it to a playlist with this. Now go back to that first result of the first one and filter it by blues and create so then there's like a list of steps or actions. And then what it does is it actually maps those to API calls to Spotify.
So, okay. So I guess I feel like which of those parts do you have to define? You're just defining the functions.
Well, so you're
The
defining
functions front ends
structure, the available functions, functionality, right? Basically, you're saying this is the API that I have from Spotify, for example.
Right, and you're
And
creating.
I'm going to take those into a type and just define what those functions look like.
Yeah.
I do have to then
hang on. When you say what those functions look like, you mean the function signatures.
The function signatures. The name of the function is called play, and it has 3 arguments. The first argument is this. The
is this type? Yeah. Okay. Yeah.
So you define that, and then you define in your handler where it actually then says if the function is play, then I'm going to call Spotify API with this.
So what it does with a complex instruction is turn it into the multiple functions that need to be called.
Yes.
And calls each one in ways that make sense. That is interesting. I'm not sure I've seen too many things that really do that. And I feel like this was something that I was asking about, whether OpenAI plugins can do this sort of thing. And the impression I got was, no, it can't. So it's very interesting that this is doing it.
Yeah, that part kind of blew my mind, because it took me a little bit to, the JSON examples were like immediately understandable. The math example was like, oh, this is kind of interesting program. Okay, but then the music example was just like, whoa, this is,
well,
this can do quite a bit.
So here's what I feel. I mean, I feel like it's interesting that it gets implemented on that. I was saying that it doesn't do slot filling, and that's a shame, but it feels like it's doing kind of the inverse of that. It's able to make multiple calls, just not multiple prompts, which is interesting.
Yeah.
That's very interesting.
So, and it seems like it handles okay, like concatenation. One of the things that doesn't work so well with, the old style intent models is if I say, I want to do this and that, then you're like, okay, what handler do I call? Because I've got, I've got 2 handlers, basically. I've got 2 different functions that you want to do. Whereas this one seems like it handles that all together. And the way that this would work with the chatbot is that you would probably, well, it depends on if it's like an asynchronous chatbot where you could, at each step, you could output something, so you could see like a bubble in the chat that says, oh, I'm doing this, I'm doing that. Or if you'd have to wait till the very end, you could build up what the response is going to be and send that whole thing back or something.
Well, I'm also thinking of things like, when you say something like, play this song on this speaker group or on this named speaker. So really, it has 3 things that it needs to do there. First, it needs to locate the song,
right,
which is a function call. Then it has to locate the speaker group, which is a function call. And then based on both of those, it needs to start playing the music, right?
Yeah.
this is tantalizingly close to what Bixby was able to do. If you remember us talking about this, 130, 140 episodes ago, the brilliant part of Bixby's capsule module is that you defined little functions that could do little things.
Yeah.
And Bixby was able to put them together based on what you had said. And this sounds like it's the first thing I've heard of that I can think of that starts getting close to what Bixby could do.
So
Very interesting.
Yeah, it is. It literally blew my mind, which I was thinking like, wow, that doesn't happen every day. That I look at something and it's just like, I think I understand it, and then it's like, whoa, that was a big surprise. And that's partly why I'm so excited about it. I know that it's in some ways it's simple and it's just a start, but it's got Anders from Microsoft, the C# TypeScript, long-term architect at Microsoft is one of the names on it. And it's something that's just been released recently, so I know it's early days. So there's a lot to kind of understand and go through it and see how it evolves. But it is open source, and it's something that you can play with now. And I found it exciting. I'm wanting to use it in some of my kind of projects that I'm working on to see how that helps me. As opposed to like hand coding the prompt to try to get the JSON to
see. And now I'm wondering if it has a LangChain or LangChain JS integration. So now I'm curious on that front.
Oh yeah, I'm not sure if it does or not, but that would be interesting.
It'd be interesting.
Yeah.
So yeah, lots of interesting stuff. I would love to hear if folks have played with it and what you've done with it, or if you've looked at other stuff that is trying to replace the intent model. I'd love to know if anyone is thinking about the slot filling issues.
Yep.
So you can find us at various social media sites, in the comments below, or lots of other places. And we'd love to talk about this another time on Two Voice Devs.
Two Voice Devs. Thank you, Ellen.
Thank you, Mark. This has been very interesting.